Today we are going to look at the graphing from factored form of a quadratic. So we'll start class by doing an activity on the calculator. And if you don't have a graphing calculator at home, you can go to Desmos, D-E-S-M-O-S. I'll write that up here, Desmos.com, and use the graphing calculator. You can type in these equations, and you'll need to match the graph to each equation and make observations of what you notice. On the graphing calculator, to graph, you could open a new graph page. I usually use the Scratchpad graph, and you type in, so for example, the first function or equation is negative, so we put the negative, and then x plus 2 it was, close our parentheses, and x minus 3, parentheses here, hit enter or graph. You can see what the graph looks like right here and then match it up to one of the graphs on your paper. So you're going to do that. I think there's 12 graphs for you to do, and once you do that, you should notice a pattern and be able to answer the following question. What do you see that helps match the graphs, to match the equations to the graphs quickly? And one thing that you'll notice by doing several examples is if we have this first function right here, equation, negative x plus 2, x minus 3, let's take a look at our graph, got an upside down shape, and we have these x-intercepts right here. One is at negative 2 and one is at positive 3. So again, you'll be looking for patterns between your factors and your graphs. So after you do the activity and answer the question, then we'll summarize in class. What you should be able to notice, so I'll write this up here. I'm going to just take that first example. So we have y equals negative, and it was x plus 2 and x minus 3. And when we looked at the graph on our graphing calculator, those x-intercepts, one was at negative 2 and one was at positive 3. So these are called the zeros of the graph. And again, if I sketch what that graph looks like, at negative 2 there was an x-intercept, and at positive 3 there was an x-intercept, and our graph looks something like this. So our goal today is to be able to recognize what the x-intercepts are by just looking at the factors, and again these are the x-intercepts, and to be able to sketch a high-quality graph of an equation by hand. So let's do some examples of that. Again, what you should have noticed in class is that the x-intercepts are the opposite of the factors. They're what makes the factors zeros, right? Because these are called the zeros of the graph. And so we take a look at what makes x plus 2 0, it's negative 2. What makes x minus 3 0, it's positive 3. So to find the zeros, you set each factor equal to 0 and solve. All right, so let's try this. We're going to do these steps for a few problems until we get the hang of it, and this is what we'll practice today in class, how to make this high-quality graph just by this factored form of the equation. Okay, so first step, if you have an equation that's factored, the first step is to find the zeros, the horizontal intercepts. Those are called many things. They're called the zeros, they're called the roots, they're called the x-intercepts, and they are when y equals 0, they're going to be along this line right here. And to do that, you look at your factored form, and we want to know what makes x minus 2 equal 0. What makes x plus 4 equal 0? And so one of the zeros, right here, what makes x minus 2 equal 0? Well, that's 2. What makes x plus 4 equal 0? Well, that's negative 4. So these are called the x-intercepts, or the zeros. Again, it's what makes your factors 0. You can set them equal to 0 and solve. So here we added 2 to each side. Here we subtracted 4 from each side. And so again, we get 2 and negative 4. Those are our zeros. It's what makes each factor 0. So I'm going to erase some of this so it's not quite so messy here. And I'm going to graph. Okay, so first step, our x-intercepts, one is at positive 2. Zoom in here, and one is at negative 4. 1, 2, 3, 4. Since quadratic graphs are symmetrical, find the line of symmetry by using the horizontal intercepts drawn on the grid. So we need to find the middle of x and negative 4. What's the middle of this right here? And again, we can kind of estimate where that middle is. It is 1, 2, 3. 3 away from each point, so it's negative 1. X equals negative 1 is the middle of the graph. To find that without counting, what we can do is find the middle of 2 and negative 4. We can average the numbers. So if you want to do it mathematically, we could take our 2 plus our negative 4, which is 2 minus 4, and divide that in half to find the middle right here. So we get 2 minus 4 is negative 2. Negative 2 divided by 2 is negative 1. So to find the x-intercepts, you take the middle of your numbers, which is finding the average. The middle is the average. So let me erase some of this right here. So again, to find the middle, we did positive 2 minus 4. It's 2 plus negative 4. We'll divide that by 2, and we get negative 1. So there's that middle line, x equals negative 1 right here. There's your line of symmetry. The middle of two numbers, again, you average them. The vertex lies on the line of symmetry. What is the value for your line of symmetry? We figured that out. That's negative 1. But now we're going to plug in and find, all right, where on this line right here, where is the point actually going to be? So let's plug in a negative 1 for x and solve for y. We need the y value. So here's what it looks like. We have y equals, and every time I see an x, I'm going to plug in a negative 1. So we got negative 1 minus 2 and negative 1 plus 4. And negative 1 minus 2 is negative 3. And negative 1 plus 4 is 3. And so we have negative 3 times 3 is negative 9. So at negative 1, negative 9, we have the y-intercept. Okay, so again, I'm going to erase my work. There's not a lot of room here. So we just plug in a negative 1. And another way that I could write this, let's rewrite this, is we could say f of negative 1. I plugged in a negative 1, and I got a negative 9. So here at negative 1, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there is our vertex is called, the vertex, where it changes direction. Okay, we got 3 points. It's looking pretty good. Let's find a few more points we can graph. Let's find the vertical intercept, the y-intercept, and that's when x is 0. So what we're looking for is where along this line would a point be at y equals 0. And again, to do that, all we do is plug in a 0 for y. So I'll call f of 0, which is just saying I'm plugging in a 0 into my equation. And here's what I got. 0 minus 2 times 0 plus 4, so that's negative 2 times 4, which is negative 8. So the point 0, negative 8, is also on this graph. And again, all we did is plug in 0 for x, solve for y. So I'm going to find 0, negative 8. And since this is symmetrical, here's our line of symmetry, I can go the same amount in each direction of my line of symmetry. So here I can plot another point. So this is what it's talking about. The vertical intercept can be reflected the same distance across that mirror line. Okay, we got 5 points, and this is pretty good. Let's just do one more to make it like a high-quality graph. Pick another value, so we chose for you, x is 3, and let's find that. So again, what it's saying is plug in a 3 for x, so f of 3, equals 3 minus 2, 3 plus 4. And we get 3 minus 2 is 1. 3 plus 4 is 7, so we get 7. So the point 3, 7 is also on this graph. So I'm going to go over 3. 1, 2, 3. And I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. Again, we can do the same thing from our line of symmetry. So this point is 1, 2, 3, 4. 4 units away from my line of symmetry, so I'm going to go 4 the other way. 1, 2, 3, 4, and make another dot right there. Let me just erase that one and that one. All right, and now we have 7 points on our graph. We can go ahead and sketch that function. Our parabola, that's our U-shaped graph. Ooh, that's okay. Let me try it one more time. Okay, so there's our parabola. We got 7 points right there. It says, did you plot the symmetric point? Yep, we did. With your 7 points plotted, here's our smooth curve. So there it is, the equation of a quadratic. You find the x-intercepts. There's the first step. You find the line of symmetry and plug that point in to find your next point. You can plot your y-intercept, and you can pick more points to plug in and use your line of symmetry to draw your function. All right, we're going to do one more, and your assignment will be like 4 of these, and just a warning on your assignment. On some of them, when you graph them, you have to scale your graph by 2s or it will not fit. Or you can try to squeeze it in if you scale by 1. All right, let's do the same strategy above. Okay, so I'm going to try to label what we did here. I'll try to use the same color. All right, so step 1, find the x-intercepts. Okay, so let's go here. Step 1, find the x-intercepts, also called the roots, the zeros, x-intercepts. Okay, so we want to know what makes x minus 5 equals 0 and what makes x plus 1 equals 0. And so you can solve each equation, or we know that here, here x has to be negative or positive 5 because 5 minus 5 is 0. And what makes x plus 1 equals 0? That's negative 1. You could subtract 1 from each side. All right, so there's the first step in blue. I'm going to graph that so where x is negative 1 and x is 5. 1, 2, 3, 4, 5. Okay, we got 2 points. Next step, let's find that line of symmetry. All right, so line of symmetry is the middle of 5 and negative 1. So we have 5 plus a negative 1 is the same as minus 1. But we want the middle, so divide that by 2. We get 4 over 2, which is 2. So our line of symmetry is x equals 2. There's my line of symmetry, x equals 2. But to find the actual point on that line, we're going to plug in a 2. So I'm going to say f of 2. Plug in a 2 and see what you get. So we get 2 minus 5, 2 plus 1, which is 2 minus 5 is negative 3. 2 plus 1 is 3. So again, we get negative 9. Doesn't happen for all the graphs, but for this last 2 it does. So we're going to go plot the point 2, negative 9. So 2 over 9 down, 3, 4, 5, 6, 7, 8, 9. I believe it's right here. Okay, next step, find the y-intercept by plugging in a 0. So step 4, let's find f of 0, the y-intercept. 0 minus 5, 0 plus 1. This is negative 5 times 1, which is negative 5. So we're going to plot the point 0, negative 5, 0, 1, 2, 3, 4, 5. Using the line of symmetry, I'm going to go 2 to the line of symmetry and then 2 in the other direction. So again, use your line of symmetry as the mirror line and graph that point. And to find another value, just pick any other point to plug in. I'm just going to pick, how about negative 2 right here? So you pick any point and plug in. I'm going to plug in a negative 2. So here's step 5. F of negative 2, which just means negative 2 minus 5, negative 2 plus 1. I should put equals here. So that would be negative 2 minus 5 is negative 7. Negative 2 plus 1 is negative 1. So that's 7. So negative 2, 7 is a point on our graph. So negative 2, go up 7. 1, 2, 3, 4, 5, 6, 7. Use your line of symmetry. It's 4 away from the line of symmetry. 1, 2, 3, 4. So I'm going to go 4 in the other direction. 1, 2, 3, 4. And graph my last point. All right, pretty colorful there. Connect using our curved line. That's okay. All right, so there's our nice parabola. Okay, so then your assignments will be to graph these. And again, some of these are going to scale by 2s to fit. So I did this. I'll tell you which ones you have to scale by 2. So this one, and but what I mean scale by 2 is like instead of every box being 1 unit, every box should be 2 units. So this is scale by 2. So this function over here, and then this one also scale by 2. And then it should fit. If you don't scale by 2, you can still make it work, but it kind of, you have to draw in some of the boxes. All right, so that's making a high-quality graph, high-quality quadratic, and you'll practice this more in the next lesson as well.